Today we are honored to have a great scientist with us. He is the father of modern physics, the founder of relativity, the Nobel Prize winner in physics, Albert Einstein.
Thank you, Athena. I am honored to have this cross-time and space dialogue with you.
Mr. Einstein, your contribution to theoretical physics is unparalleled. You also have important research and discoveries in the field of superconductivity. Can you briefly introduce what is superconductivity?
Of course. Superconductivity is the phenomenon of some materials losing their resistance at low temperatures. This means that current can flow through these materials without loss. This is a very wonderful and interesting physical effect, which involves the interaction of various factors such as electrons, lattice, magnetic field, etc.
What is the application value of superconductivity?
Superconductivity has a lot of potential application value, such as making powerful and stable magnetic fields, which can be used for nuclear magnetic resonance imaging, particle accelerators, maglev trains and other equipment, or achieving dissipationless current transmission, which can improve the efficiency and safety of the power grid, or developing new quantum computing and communication technologies, which can break the limitations of traditional computers.
It sounds very magical and promising. But superconductivity also has a big problem, that is, it requires extremely low temperatures to achieve. This increases the cost and difficulty, limiting the widespread application of superconductivity. Therefore, scientists have been looking for materials that can achieve superconductivity at higher temperatures, even at room temperature. Is this possible?
This is a good question. I think achieving superconductivity at room temperature is not impossible, but not easy. We need to understand the relationship between superconductivity mechanism and material structure and find suitable element combinations and conditions to create a stable superconducting state at room temperature. This requires a lot of theoretical calculations and experimental explorations.
As far as I know, some research teams have reported new records of achieving superconductivity at room temperature recently. They used a compound containing hydrogen, sulfur, and carbon, which can show superconductivity at temperatures up to about 15 degrees Celsius. But this superconductor can only work under pressures up to 267 GPa, equivalent to 3/4 of the pressure at the center of the Earth. Does this superconductor have practical value?
This is a meaningful breakthrough. It shows the potential of hydrogen element in having high-temperature superconductivity under high pressure. But this superconductor is currently not suitable for practical applications because it requires extreme pressure conditions and the sample is very small and unstable. We need to find a way to reduce the pressure requirement or increase the size and stability of the sample. This may require introducing other elements or changing the way of material preparation.
What do you think is the future direction of superconductivity research?
I think there are two directions for future superconductivity research. One is to continue exploring the superconductivity of hydrogen element compounds, trying to achieve superconductivity at lower pressure and higher temperature, or finding other elements or compounds with similar characteristics. The other is to explore new types of superconductivity mechanisms and materials, such as topological insulators, graphene, nanostructures, etc., which may have different physical properties and application potentials from traditional superconductors.
Thank you very much for your wonderful sharing, Mr. Einstein. I believe your thoughts will inspire more scientists and young people to pursue scientific truth and a better future.
You're welcome. I also enjoyed talking with you. I hope you can keep your passion and curiosity for science and explore the mysteries and possibilities of nature.